Hello, and welcome to the Badger Talks podcast, the podcast that shares interviews with experts from the University of Wisconsin-Madison community about their work, research, and a little bit about what they're like as people, too. I'm your host, Buzz Kemper. Today, I'll be talking with Sarah Stevens, Director of the Data Science Hub at the University of Wisconsin-Madison. Sarah Stevens, welcome to the program.
Hi.
Hi, thanks for doing this.
I'm pretty excited.
Good.
I'm interested.
I have interviewed a lot of people for Badger Talks podcast, and we usually talk about some area of research which they are interested in, and kind of what they're finding out, and we kind of zoom in on that sort of thing. You're a little bit more zoomed out. You are facilitating and helping the people who are doing the research, and so you have this kind of upper tier role, I guess. Is that a decent way to describe it? Or
I usually describe it as research support. I help researchers. I was a researcher, and I've seen things that we can do to help researchers do their work better.
Okay. So tell me about that. First of all, how did this come about? You were doing your own research. You're a microbiologist.
Yeah, so I actually came to UW when I was a graduate student for the microbiology program.
Okay.
We have a really great microbiology program here at
Yes.
UW-Madison,
Yes,
one
we
of the
do.
first in the nation.
Yeah.
And I always was kind of interested in this intersection of computing and biology.
Mm-hmm.
And in my undergraduate degree, I'd done a minor in informatics and learned a little bit of computation there. And so when I came to grad school, there were a lot of students in my program, about 20. I think 2 of us knew how to write programs, how to code. And in the time I was in grad school, I think maybe 2 people left the program without having to learn to code when they graduated. So I kind of see this big gap in biology, but it's true in a lot of research areas generally, where we're trained to know our domain really well, like biology or digital humanities or geography or whatever the area is.
Mm-hmm.
But we don't necessarily get formal training in doing data analysis, data science, computing. And those are skills that are really helpful for doing most of research today because we can collect so much information with computers.
Yeah.
And so as a graduate student, I found myself helping a lot of my peers learn to code. I helped them, apply those skills in their own work. And that's kind of what led me to the job I'm in now, is I wanted to keep doing that. I wanted to keep helping people. And the Data Science Hub job was open here at UW-Madison. I was the first employee.
Wow.
And so I kind of was able to figure out what researchers need based on my own experiences and develop the program that we've put together.
Okay. I never had thought about this until I actually read your bio and started thinking about what to talk about, was that we know that in science there are computer models that people set up to say, I have this theory, I want to test it, and one way I can test it is through computer modeling. But there's a little bit of a gap there to be bridged. There is, what is the test? How did you come up with your theory? But then there's, how do you make the computer do what you need it to do? And so how, in the absence of someone like you, how is that handled?
Yeah, so a lot of researchers are using things like Excel to work with large amounts of data. Okay. Sometimes Excel doesn't do that particularly well. It doesn't handle large amounts of data for sure. But also, one of the downsides to a tool like Excel, which is useful for a lot of things, I don't want to sound like I'm saying Excel is a bad tool, but it's useful for a lot of things.
The Excel police are coming in right now.
Well, tools that people are using are still useful tools, right? But it doesn't do things like record what you're doing. So if you need to make a graph, for example, and you get new data, you have to do the exact same steps of clicking to make that new graph, and you have to remember what you did. If somebody else goes to do it because they're like taking on your work or like taking the next steps on your work, they don't have any record of what you did when you clicked on the screen, right? And so things like formal coding, like with languages such as Python and R, they're the documentation as well as the tool that actually does the operation in the computer, right? It actually does the calculations. And so that documentation of making a graph is there and you can rerun it. When I teach about data visualization in particular, I always tell this story with my advisor, and every time I would give her a figure of my research. She'd be like, oh, this is so exciting. And she would go to make it a publication quality figure. So she'd make the font bigger in Illustrator and the lines thicker. So it was a little bit more.
So when you say figure, you mean like graph?
Yeah, a graph.
Okay,
Yeah, a graph
cool. Right.
for my paper. And so she'd go do that in Illustrator. And I'd get more data, or I'd decide that I needed to change the analysis in some way. And I made that plot probably more than 10 times at least.
Yeah.
And so eventually I stopped her and I said, hey, tell me what you're changing. I'll write it into my code. And then every time I'd make a change, I press the button. In less than a second, that plot is remade and you don't have to hand edit it.
So it'll recalculate.
Yeah,
and
it
make
does
a
the
new...
same thing each time, right?
Nice.
And it's all written in my code so that it's really reproducible, which is what I care a lot about and think a lot about in my work, is how to make research more reproducible in the computational space.
Okay. So now this leads me down another path. So first of all, for people who are not programmers, Python and R, are those languages or systems, or what box do those fit into?
Those are both programming languages.
Okay.
R is a statistical programming language, so it was written for statisticians originally, and some of which was developed here at UW-Madison actually as well. Python is more of a general programming language, so it doesn't by default do a lot of statistics stuff, but it has the ability to do statistics and other things as well.
Okay. And this program that you're talking about, where someone can find new data or adjust the data that is on a graph that you have already made, and then you can literally just push a button and it will redo the graph with those changes. That I'm getting the impression that is not a program that existed in the world. Like, did you invent that?
Well, so those capabilities are all in the programming languages.
Okay.
So one of the things I love about R and Python in particular is they're both what are called open source languages. So anyone can use them without a license. You don't have to pay a fee to use those programming languages. And because of the system that's built around that open source, people have made packages. So they've made some code that I can pull into my code that makes it easier to make a pretty plot, for example.
That's so cool. So somebody actually thought it would be better to have this be open source than to get someone rich. That's very cool.
Yeah, I work actually earlier this week at the event I hosted. We had an open source award. So there's a lot of work going on. And actually, that's one of the things I'm very passionate about, is that publicly funded research should be open for the public to be able to access and use the outcome of. And so I really am passionate about open source in particular because I think it makes building upon previous research easier, right? It's not locked behind a paywall. You're showing exactly what you did. So that also makes your work more reproducible, which is, I think, better. And so it makes it possible for researchers to continue to build on your work a little easier, or for you to reuse what you've made.
Yeah, one of my favorite sayings is the only thing that beats science is better science. And so open source is going to lead to that. So tell me how your job works in the real world. What is a day like for you in terms of helping? Is it graduate students or other professors? Who is it you're working with, first of all?
All of those. So
all of
our
the above.
primary audience, the people we get the most of coming to our services, are graduate students.
Okay.
A lot in the life sciences. I think that's because that's an area that people have identified, or health sciences as well.
Right.
An area that people have identified the need for these skills, but it's true across all domains of research that they need these skills. So that's the audience. But the day-to-day is pretty variable as a facilitator in the Data Science Hub, the team I work on.
Okay.
Some days we're hosting workshops. Like next week, we're going to host a couple workshops during spring break, and we'll be teaching some of those workshops. We also organize the community of instructors that teach it. So there's instructors that are graduate students, librarians, et cetera, that come and participate and help teach our workshops. And so we organize them and we help teach them, but we aren't always the instructors at them as well.
Okay.
And so sometimes we're doing workshops, sometimes we're doing consultations. So twice a week we have kind of walk-in office hours that we call coding meetup, where people can come by and be like, hey, I need help making this graph. How do I apply R to make this graph? Or I've heard I need ggplot. How do I make it work? And so we'll answer specific questions.
Yeah.
And then other times it's hosting events and bringing people together to learn from one another. So this week we hosted hosted, it feels like last week because it's been so busy.
Yeah, right. I know. Yeah. We live in a time warp, I think.
Yeah. But this week we hosted the Research Bazaar. That's our big event where we bring together people across all disciplines to kind of share the data science that they're doing in their research,
right.
And learn from one another. But we also host things like a community of practice called ML plus X, which stands for machine learning, AI basically.
Okay.
For most people, they think of it as AI.
Okay.
Plus X, which means whatever research you're doing is that X. And so we bring together people to talk about how they're using specifically machine learning and AI in their own research and learn from one another as well.
Can you tell me an interesting story of someone who was stuck in part of their research or in trying to graph their research and you alone or you in cooperation with the student or the professor were able to find a solution and boom, it came together?
What's funny is I feel like there's no one specific story that stands out because it happens. It's so frequent.
Oh, it happens just all the time.
It's just all the time when people come. I mean, I'm more familiar with the genomics things, and so I usually end up answering a lot of the genomics questions. But one of the times that stands out to me a little bit more recently is somebody came to me, and I can't remember exactly what their problem was or even how we solved it, but they were stuck because they were trying to use generative AI to try and write code for them to solve whatever problem they had. And they came to me, who has a little more experience with working with that code, and they didn't, which means they had trouble using Gen AI for it. And that's one of the things that I've really seen a lot, and we've talked about a lot lately about AI, is that you can't use it to code very well if you don't know how to code already. So it's sort of an issue that's been coming up a lot in our work. This person came to me and they said, I can't get anything to work that I've tried with the generative AI tools. And I was like, yeah, let's step back and talk about what your problem is. And again, I don't remember what it was, but we worked through it. And at the end, not uncommonly, researchers leave being like, I was so stuck, and just this half hour with you made progress that I can move forward now. And I love hearing that because I'm like, yes, that's what we're here for, is to make sure that you don't spend days, weeks trying to solve a problem that we can help you with.
Yeah, just spinning wheels, and that would be really frustrating. That's interesting to me. I never thought about that, but I've heard people say that one of the things that the human brain has the most difficulty comprehending is the human brain, is itself. And so this is kind of an example of that. Like AI, which is code, has trouble generating code. Why?
It's not terrible at it.
Take me out of that maze.
It's not terrible at it.
Okay.
But it's not great when you don't already know how to code, basically, because so people who know how to code can write really good prompts to help it figure out what it should write. Because the things we're talking about are what are called large language models. And so they're really good at basically text prediction and predicting what word should come next. So you're giving it a prompt that kind of gives it the context, right? And then it predicts the words that should come next based on that context.
Okay. So you have to know what a sentence is before
you have to know what you're asking it, right?
Okay.
So like if you asked it to write something for yourself personally, like a letter of recommendation or a bio or something like that, like what it's going to write, you're probably going to need to edit it. And the same is true for code. And if you don't know how to edit it, then you're going to get stuck because it's not going to give you a perfect solution. It's going to give you what probably the next word should be.
Right. And if you don't know what the next word should be and it puts in something incorrectly, then you're just going to be stuck with that incorrect spelling. I totally get that. Okay.
AI was actually the theme of the conference that we hosted this week, and ML, and how the opportunities and boundaries that we see in research for its application. And that really came up a lot of times in some of the perspectives that were like, we can use this, but we need humans in the loop. We can't expect it to do things and get things right. It gets things wrong a lot of the time, and it might get better, but it still needs that context, that prompt that a human is creating to know where to go, or doesn't really know. I always hate using the word go.
I doubt if I'm the only one who thinks this, but I find that comforting that we still need humans in the loop. I mean, I don't want us to become obsolete. How did your position come into existence? Did it occur to you, or did the university say, we have this gap between people wanting to do their research and knowing how to code in so that they can graph and track their research? We need someone who can fill that gap. Or how did the whole idea of your position come into existence?
Yeah, so when they wrote the position, it was actually because, I guess the full story is the new director of the Wisconsin Institute for Discovery, Jo Handelsman. She's currently the director, but she was new at the time.
Okay.
And she came and kind of started these conversations about what we need around data science. And my boss, Michael Ferris, who's a professor in CS, and another professor in statistics, Brian Yandel, and a few other people as well, kind of came together and hosted a town hall. And we're talking about what are the next steps for UW around data science? What do we need? How can we fill this gap? And so then they put together a proposal for a UW 2020 grant and from WRF. And that was the funding initially for my position and a couple others that we started in the Data Science Hub. And so, they realized that they needed somebody to kind of help researchers in their domains fill this gap.
Right.
Because, people in data science and computer science, they're doing what they can, but there's only so much they can do. They're also teaching the data scientists and the computer scientists, right? And so we need people who can kind of help the people in domain researchers and research biology, digital humanities, engineering, some of those areas, and help them learn these skills and work on it. So that's the initial interest in my position, or the put together for my position.
Okay.
I don't
so
like my
when
words
Jo
there, but
then had this position, were you here already?
I was a graduate student nearing the end of my PhD.
Okay. So you were just like, here's a door, I'm going to walk through that.
Yeah. It's funny, though, is that I actually didn't find my position from UW. I found my position through a global community that we actually use a lot in the Data Science Hub now.
Wow. Okay.
Called the Carpentries, where we create open lessons on how to teach these skills.
I saw something in your bio about the Carpentries, and I thought, I don't think she builds furniture.
No. Yeah. It's a weird name.
Tell me about this. Yeah.
And so the Carpentries is a global community and a nonprofit based here in the U.S. that supports the community that makes open lessons on learning the skills that we teach in the Data Science Hub.
Okay.
So things like R and Python that I mentioned before and many others. They create these open lessons that are available on the web, and that any researchers teach them teach them to other researchers across the globe.
Right.
And so I really, I'm a big fan of open source. So I really like that we can also share creating these lessons together. And I loved that when I was a graduate student, because I didn't have that confidence in that I knew this tool well enough to put together a full training on it, right?
Okay.
But I went to the Carpentries community. I joined the Carpentries community, and I was like, oh, I really like what they're teaching about Python, and I could teach this too. And that's kind of a lot of how I developed my teaching skill as well. And that community shared this position with the people in the community, and that's how I found it.
Oh, that's terrific. Okay. Was there a lot of competition for the position? I mean, I imagine what you do is fairly arcane. Like, I don't think a lot of people, there aren't 10 million people doing this, unless I'm wrong.
It is kind of a unique skill set in that it's somebody who has computational skills and communication skills and wants to use them to help others rather than do that work themselves. Because we get a lot of people who apply who I can tell are more interested in the data science side. They want to do data science. Right. And so it's kind of always a sorting process of trying to find a person who really wants to help others do data science rather than do it themselves. Because they won't be happy in this role if they...
makes
came
sense.
To it, yeah.
Well, that's so great that you do what you do. I mean, we'll never have any way of knowing how much quicker and how much more efficient some of this research is advancing because of what you do. So So good on you.
It's really hard to kind of track. Like we try because we're data scientists too, and we're interested, right? And so we try to put together an annual report every year, and we try and make it better and better at incorporating more and more of like what we do. But I think the thing that we still struggle with is the things that aren't numbers. We can put together how many people attended a workshop and how many people came to our events and those like number things,
right?
But the things that I always find really impactful are the stories people tell me of like, this was really helpful. And we don't collect those in the same way. And maybe we need to get better at doing that. But we usually have a few quotes in our annual report, but I'd really like to figure out how to better collect that. I think I need to consult with the social scientists on campus, actually.
Okay, there you go. Yeah, there you go. I mean, hey, scientists helping each other. That's what you're all about. That's terrific.
I mean, yesterday in my conference, there was a question about, with AI in particular, what skills we as humans need to kind of get better at working with AI and, be prepared for the challenges that it presents. And one of the answers from one of the panelists was around the idea that we need interdisciplinary science. So we need people who are in health and law and data science to come together and be able to like talk to one another and learn things. And it was like kind of the culmination of that event to me, because that's the whole reason we bring together that event, right? Is to bring together people across various fields in the Interdisciplinary Research Institute. And data science is this kind of common language that a lot of people are using in research.
Right.
And so I found it really kind of interesting that they thought that the interdisciplinary was kind of the things that we needed to focus on to kind of be prepared for the next steps in working with AI and ML. But I kind of feel like it's the thing across research generally that's really helpful is that data science is its own thing, but it's also in everything. And computers are in everything. And so I really feel like that bringing people together to learn from one another, talk to one another, is kind of really vital in the research that the campus is doing, is having them be able to talk to one another. And actually, the RISE initiative that the campus has put together is around that. It's like kind of these cross-cutting themes that are cross-cutting a lot of research across the campus, not so departmental focused, but hires in many different departments that have these cross-cutting themes. And so I feel like we're kind of making progress towards that solution already. I was kind of happy to hear it.
Yeah. People from different disciplines talking to one another. What a concept.
It's a challenge. I think because of the history of science is that it was so, and research at large, is that it was so disciplinary, right? Like, and you could focus on your discipline, but now a lot of the work we do needs to be that cross-cutting, cross disciplines.
When you're not immersed in all of this, what do you do when you've got time off, when you have time to relax? You have hobbies, sports, anything like that?
I do like riding my bike, and I look forward to I have an e-bike and I love riding it. I look forward to the warmer weather. Lately, I haven't been spending a lot of time on it because I had a baby about a year ago.
Wow.
He's been taking up a lot of my free time.
I've heard that children take time.
He's an interesting little experiment, for sure.
I bet. I bet. Wow.
Lots of observations of his growth.
So how old is he now?
He's just over a year.
Just over a year. Wow. Okay. Very cool. Yeah, that is definitely something that requires some time. Well, yeah, I can't wait to get on my bike either. My bike is being tuned up and prepared for the season as we speak. So hopefully I can pick it up in a day or two and
I need to prepare. I need to merge those two things because I got the baby a helmet, but I haven't figured out how, I don't have anything to take him on the bike. I don't have a trailer or anything.
Oh,
so
yeah. People have these little buggies that they pull behind.
I've been thinking about putting him on a seat on the back because there's like toddler seats.
Fair enough. Well, you know more than I do.
Mount to your back rack.
Okay. Well, I have exactly 0 children, so don't take any advice from me at all.
I only have the one replicate so far.
Fair enough. All right. Very good. Well, that's one more than me. Sarah, thank you so much. This has been really enlightening, and the fact that I now understand your position better, whereas before we set this up through Maya, I didn't even know such a position existed. So thank you for being here, and more than that, thank you for doing what you do. I mean, you're helping science move forward, and we certainly need it.
Thank you for inviting me to join and share my experience and background in helping researchers and being a researcher.
You've been listening to the Badger Talks podcast. I hope you enjoyed this conversation with Sarah Stevens, Director of the Data Science Hub at the University of Wisconsin-Madison. Please browse our previous episodes for other topics that may be of interest to you. The Badger Talks podcast is a creation of UW Connects and produced at Audio for the Arts Recording Studios in Madison, Wisconsin. Our music is composed by Bill Purdy and performed by the UW Marching Band. I'm Buzz Kemper. Thank you for listening. AI, which is code, has trouble generating code. Why take me out of that maze?
It's not terrible at it.
Okay.
But it's not great when you don't already know how to code, basically, because so people who know how to code can write really good prompts to help it figure out what it should write. Because the things we're talking about are what are called large language models, and so they're really good at basically text prediction and predicting what word should come next. So you're giving it a prompt that kind of gives it the context, right? And then it predicts the words that should come next based on that context.
That's Sarah Stevens, Director of the Data Science Hub at the University of Wisconsin-Madison. With a PhD in microbiology from UW-Madison, Sarah is passionate about empowering researchers to leverage data science in their work. That's this time on the Badger Talks podcast. I'm Buzz Kemper. Join me via the podcast provider of your choice.